All right, in this video, we are going to work the following problem. It says if the tangent of t is equal to 1/2, find the other 5 trig functions of t, and where t is in quadrant 3. So the first thing that you want to do is sketch out this situation. All right, so there is our coordinate axes, and remember our angles in standard position, so that means the vertex is at the origin. The initial side points in the positive x direction, and since this is a quadrant 3 angle, right, the terminal side will be down in the third quadrant, right? And remember somewhere that terminal side meets the unit circle, right, wherever that point is, right? And so in that point, we need to make sure that we realize what the signs of those are, okay? And so that means that any point that's down in the third quadrant, right, will have a negative first coordinate and a negative second coordinate, right? So this point down here, both of the coordinates will be negative, right? And so that means that the cosine, right, which is the first coordinate here, will be a negative. Okay, so that means the secant will be negative as well. The sine will be negative, right, because the second coordinate is negative. And that means that the cosecant, right, would be negative also, right, because the cosecant is 1 over the sine. And then tangent and cotangent will be positive, right? Because on both of those, you would be dividing a negative by another negative, and so that would come out to be a positive. All right, so it's important to work this out because somewhere along this line in this problem, we're going to have to make a choice, and these points here, these signs of the points down in the third quadrant are going to guide that decision. Okay, so the first thing I'm going to do is work on the secant, and that's because of the following identity, right? We have one of the Pythagorean identities that says 1 plus tan squared t is equal to secant squared t. All right, so we are going to use this identity. The reason why we're using this identity, right, is because we know tangent, right? We know what the tangent is. It's 1/2. And so we can replace tangent over here with 1/2 and figure out what the secant is pretty quickly. So, all right, I'm going to move off to the side here. And then I am going to replace tangent by what I know it's equal to 1/2. And remember, this is tangent squared, right? So that means it's going to have to be 1/2 squared. And so that's equal to secant squared. And now I would just simplify this out, right? The next step, I need to simplify this left side as much as possible. And so 1/2 quantity squared, right? If I'm squaring a fraction, I just square the top and square the bottom. Or just do 1/2 times 1/2. All right, and then 1 squared is 1, 2 squared is 4. All right, so now that's a little bit simpler, and what I want to do is just combine these two terms over here. I need to add 1 1/4, right? In order to add these two, I need to get a common denominator, which would be 4, right? And I would have to write 1 as some number over 4. Well, that obviously, right, is going to be 4 over 4, right? Because 4 divided by 4 is equal to 1. All right, and then keep going. So this is going to come out to be 5 over 4, right? When I add fractions, I add them with common denominators. I add the numerators. 4 plus 1 is 5, and I keep it over the same denominator. And so that's what I get. Okay, so if what you want to do is get secant squared by itself on one side, which it already is. There's really nothing to do. Once I simplified both sides, the secant was over here by itself on the one side. That's exactly what I want to have happen, right? Because if secant squared is by itself on one side and a number is over on the other side, a positive number, I know that there are two solutions, right? And those two solutions are plus and minus, right, the square root of 5/4. So that's the square root property that we've been talking about before. All right, and then I can simplify that out. I'm going to split this up into square root 5 over square root 4 because I do not want to leave a fraction underneath the radical sign. And the square root of a fraction like this would be the square root of the top over the square root of the bottom. And then the square root of 4 is 2. All right. Okay, so now I know that the secant, right, of t is either equal to plus or minus the square root of 5 over 2. So now I need to make a choice. Okay, which one is it? Is it the plus one or is it the minus one? In order to make that choice, I'm going to have to go back over here, right, to this diagram that I drew up at the beginning. And we know that down in the third quadrant, right, we know that the cosine would be negative, right? And if the cosine's negative, we know that the secant would also have to be negative, right? Because the secant, according to the identities that we talked about in the previous section, right, the secant is 1 over the cosine. So 1 divided by a negative number, right, would come out to be negative. So that gives us one of the other 5 trig functions. I'm going to write that way up here to try and save some space. So we know that the secant of t is equal to negative square root 5 over, square root 5 over 2. All right. So now that we know the secant, right, we can easily figure out what the cosine is, right, because the cosine would be 1 over the secant, right? You flip over the secant, you get the sine, or cosine, flip over the cosine, you get the secant. So this would be 1 over negative square root 5 over 2. Okay, again, because of the identities, we know that's the relationship between secant and cosine. Here I'm dividing by a fraction, right? So what I would do is change that to multiplication, right? 1 divided by this fraction is the same as 1 multiplied by the reciprocal of that fraction. So that would be minus 2 over square root 5, like so. That comes out to be minus 2 over square root 5, right? Because 1 times anything is itself. All right, so we have the cosine, but remember, you don't want to leave a radical in the denominator of a fraction like this one here. Okay, and so that's one of the rules they have to go by in trig in this class. And so to get that radical out of the bottom part, what you would need to do is to multiply both top and bottom, right, by the square root of 5. In this case, it's only square root 5 in the bottom, right? So what will happen is by multiplying both top and bottom by square root 5, this is going to cancel out the radical in the bottom, right? And then to keep everything balanced out, you have to multiply the top by the same number. Otherwise, you're going to be changing the value of that number, right? So in the top, I get minus 2 square root 5. In the bottom, I get just 5, right? Because square root 5 times square root 5 will be square root of 25, which is just 5. So you can see now there is no longer, right, the square root in the bottom part. Okay? All right, next up I am going to go after the sine. Let's do that one next. All right, and in order to do the sine, I'm actually going to use this identity. Is the identity that I want to use is for the tangent, right? I know the tangent is 1/2. I know cosine is minus 2 square root 5 over 5, right? And so I know that the tangent is equal to sine over cosine. So I know the tangent, I know the cosine, right? And so therefore I can just solve this out. I know the tangent is 1/2, right? So I could put 1/2 over here. Sine, I don't know. That's what I'm trying to figure out. And the cosine is minus 2 square root 5 over 5. All right. So you can use this, right? But in this problem, it's actually a little, yeah, this is the one I want to use, right? You could actually use this one, but it's going to save you a little time if you use this one right here. So minus 2 square root 5 over 5. Okay, so now I just need to solve that out. And the way that I'm going to do that, right, is to multiply both sides by this number here. So minus 2 square root of 5 over 5. All right, and then I'm going to do that over on this side as well. Minus 2 square root of 5 over 5. Like so. All right, and if this confuses you because you're starting to have a, quite a big number of fractions, you can always kind of think of it like this, as this is being over 1. And now what I have is the common factor between the top and the bottom over here. I have minus 2 square root 5 over 5 in the top, minus 2 square root 5 over 5 in the bottom. And so those can cancel each other out. All right, and then over on this side, you're going to have just sine t left. Okay, and then over here on the right, I need to multiply these two out. That's pretty straightforward, right? I can see I do have a common factor of 2 between the numerator and denominator right here. And so I can cancel that out. 2 goes into itself once. It goes into -2, -1 times. So when I multiply the tops here, -1 square root 5 times 1, that gives me minus square root 5. And on the bottom, I have 5 times 1, which is 5. Okay. Next up, I am going to do the cosecant. All right, and for the cosecant, right, I'm going to use the fact that it's 1 over the sine, right? And I know what the sine is. The sine is minus square root 5 over 5. Okay, and so now I have 1 divided by negative square root 5 over 5. That is equal to 1 times 5 over negative square root 5. Right, dividing by a fraction is the same as multiplying by its reciprocal. And so I get minus 5 square roots of 5, like so. And I will still need to rationalize this, right, because I have a square root in the bottom part of this fraction. So square root 5, multiply top and bottom by square root 5, and I get that the cosecant is equal to minus 5 square roots of 5. And on the bottom, square root 5 times square root 5 just comes out to be 5. Okay. Now I can see on this one I have a common factor between the top and the bottom, and so I will need to cancel out that common factor. 5 goes into itself once, it goes into this 5 one time. So I get minus square root 5 over 1, which is the same as minus square root 5. All right, so there's the cosecant, and that leaves us with just one, and in fact it's probably the easiest one, and that is the cotangent, right? The cotangent is, we know from using the identities that the cotangent is 1 over the tangent, right? And we know the tangent, right? It's 1/2. So it's going to be 1 over 1/2. And remember, that's the same as 1 times 2 over 1, right? And when you multiply this, that's going to be basically 2 times 1, right? Which comes out to be 2. and that is the cotangent. All right, and that is all there is on this one.